Hi everyone and welcome to the internet. What we're going to be doing in today's lesson is having a look at mole calculations. So we've already looked to see what moles are in previous lessons. Now what we're going to do is have a look to see what we can do with them in terms of calculations. So hopefully by the end of this lesson you're going to be able to use these moles to calculate different things. Starts off though, we've got 3 questions based around some of our previous work, so have a go at answering those 3 questions in your books. Let's mark those answers. So for question 1, the Avogadro constant is the number of entities in 1 mole, which is equal to the number of atoms in 12 grams of carbon-12, which is 6.02 times 10 to the power 23. So 1 mark if you got the number, 1 mark if you got the definition. Question 2, a mole is an amount of a substance that contains the same number of entities as there are atoms in 12 grams of carbon-12, 1 mark for the whole definition. And then for number 3, it would be 6 divided by 500 divided by 1000, which is 12 moles per decimeter cubed. So 1 mark for that. Totals out of 4. What we're going to do first of all then is use a formula that's going to become very familiar to you. This is something that's going to keep popping back up throughout the course. So make sure it's one you add to your flashcards to learn, which is the mass in grams is the molar mass in grams per mole times the amount in moles. Now you could be asked to rearrange that, and therefore you need to be familiar with it and know how to rearrange it. And you can use the triangle method easily for that. The best way I think we can use this is to actually look at an example first of all. So what I've given you in the second box is a style of question that we might encounter. So nitrogen reacts with hydrogen to produce ammonia, and then we've got the balanced symbol equation there. Calculate the mass of ammonia made from 84 grams of nitrogen. So what I'd suggest you do is jot down that question first of all, and then we're going to work through it one stage at a time so you can see how we use that formula at the top. The first thing we're going to do, and this starts just under the smaller line, which is the question there, is we need to calculate molar masses. And we need to calculate the molar mass of nitrogen and of ammonia in this case. Because we're not actually concerned with hydrogen, because if we look at our question, it asks us to calculate the mass of ammonia made from 84 grams of nitrogen. So nitrogen we have a mass for, and we're calculating the mass of ammonia. Hydrogen is irrelevant to us here. So to work out the molar mass of nitrogen, which has got the formula N2, get the periodic table out, look up the relative atomic mass for nitrogen, and you'll find it's 14. Because we've got two nitrogens, we do 2 times 14, which gives us 28 grams per mole. And then we do the same thing, but for ammonia, which has the formula NH3. So what we've got there, nitrogen is 14, and we've got 3 hydrogens, so we need to add 3 times 1 onto our 14, and that gives us 17 grams per mole. So that's our first stage, is working out the molar mass of the 2 relevant chemicals. Stage 3 is where we use our formula from the top. Now in this case we've got a mass in grams and we've got a molar mass, and therefore we can find out the amount. So we need to rearrange the formula at the top to make amount the subject. So amount is the mass in grams divided by the molar mass. Then we can substitute in our values. So from the question we've got 84 grams of nitrogen, so the mass, we write 84, and then we divide that by the molar mass of nitrogen, which was 28. Put that into your calculator and we get the answer 3 moles. So we have 3 moles of nitrogen. The next step is we need to look at the balanced symbol equation. So we're only looking at nitrogen and ammonia again. So if we look, we've got 1 mole of nitrogen because there's no number in front of it, so that tells us it's 1 mole. And that's going to make 2 moles of ammonia because there's a 2 in front of the NH3. So 1 mole of nitrogen makes 2 moles of ammonia. But in our little calculation we just did, we worked out there's 3 moles of nitrogen. So apply the same proportions. If 1 mole makes 2 moles, then we start with 3 moles, we'll make 6 because it's twice as much. So we can say we're going to be making 6 moles of ammonia. What the question actually asks us to do is to calculate the mass of ammonia though. So we go back to our formula at the top. This time we're going to use it as I've written it at the top there. Mass is the molar mass times the amount. So what we need to do is we substitute in the molar mass of ammonia, 17, and we multiply that by the amount in moles, which we just worked out was 6. So 17 times 6 into your calculator, and we get 102 grams. And that's the answer to the question. So while these may look complicated, actually all we're doing is using that one formula at the top, 2 different ways, and just working through this logical process. So we always work out the molar mass first of all, then work out the amount of the thing you can, look at your balanced equation to find your ratios, and then apply that to the amount you have, and then back to the formula at the top to work out the mass in grams of what you were asked to. And that's how we can solve each of these. Let's see how you do. Here's another question. Have a go working through those steps, one bit at a time, showing all of your working, and see if you can find the answer to this one. So let's have a little look to see how we solve this then. Calculate the mass of nitrogen needed in a reaction with excess hydrogen to produce 6.8 grams of ammonia. So as we've read it, what we've done is we've underlined, circled or highlighted the key bits of information. So here we're only concerned with nitrogen and ammonia. Now, just in case we don't remember, this equation is going to be nitrogen plus hydrogen makes ammonia, so NH3. And if we quickly balance that, then we have a 2 there and a 3 there. So there's our balanced symbol equation. The first thing we need to do is we need to work out our mass of nitrogen. So we're looking for the molar mass of nitrogen. So if we start off with our nitrogen, then look on the periodic table and we find that nitrogen has a relative atomic mass of 14 and we've got 2 of them. So 14 times 2 gives us 28 grams per mole. Do the same thing for ammonia, which is NH3. So nitrogen is still 14, and onto that we need to add 3 of our hydrogens, which has a mass of 1. So 14 plus 3 times 1 gives us 17 grams per mole. So we've got our relative formula masses here, okay? Now, the next thing we need to do is think, what can we work out? We've got, obviously, the molar masses of 2 chemicals, and we have a mass in grams of ammonia. So that means that we can do the mass of ammonia, so 6.8, divided by its molar mass, which is 17. So 6.8 divided by 17, which gives us 0.4. And that is the amount in moles. Because remember, the amount in moles is the mass in grams divided by the molar mass. So we know we've got 0.4 moles of ammonia. Now, what we can then do is look at our balanced equation. So we don't need to worry about hydrogen, that's kind of irrelevant to us. We're looking at nitrogen to ammonia. So in our equation, 1 mole of nitrogen is going to react to make 2 moles of ammonia. But we're only going to be making 0.4 moles of ammonia. So we can apply the same ratio. If 1 mole of nitrogen made 2 moles of ammonia, then all we need to do is 0.4 divided by 2, which gives us 0.2 moles of nitrogen. Then from that we can do our 0.2 times by the relative formula mass, which is up here, which is 28. So 0.2 times 28, and that's going to give us 5.6 grams, which is our answer. Give you another chance. Here's a second question to have a go at. Okay, let's mark this one then. So sodium hydroxide reacts with chlorine gas to make bleach. There's our balanced equation. If you have a solution containing 100 grams of sodium hydroxide, what mass of chlorine gas is needed? So first thing that we need to do then is work out our molar mass of sodium hydroxide and of chlorine. They're the two we're concerned with. So sodium hydroxide, sodium has a relative atomic mass of 23, oxygen is 16, hydrogen is 1. So that gives us 40 grams per mole. And then chlorine is 35.5, and we've got two of them, based on the little two down there. So that's 71 grams per mole. So we've got our molar masses. Next thing, we work out the amount of the chemical we can. So we've got sodium hydroxide is 100 grams. So we're going to do 100 divided by our 40. And that will give us 2.5 moles. Then look at our balanced equation up here. 2 moles of our sodium hydroxide reacts with 1 mole of chlorine. We've actually got 2.5 moles this time. So 2.5 is going to react, keeping the same proportions, with 1.25 moles. And then the last thing we need to do is, and I'm going to come over here because I've run out of space down there, 1.25, so the amount in moles times the molar mass, which is 71, and that gives us an answer of 88.75 grams. So what you can do is give yourself 1 mark for your molar mass of sodium hydroxide, 1 mark for the molar mass of chlorine, 1 mark if you worked out the number of moles, and then you can have 1 mark for the answer. So it'll give you a total out of 4 for that one. What we need to look at then are a couple of key terms we use in chemistry. So we've got the term excess and limiting reactant that we need to know what they mean. Wherever you see that there's an excess of something, then that's the reactant that's present in a greater amount than that needed to react with the other reactant. So we've basically got a surplus. We've got more than we need of that one. So the one that's in excess is never going to be something you're using in your calculation. The limiting reactant is the one that's present in an amount less than that needed to react completely with the other reactant. So the limiting reactant is the one that's going to run out first. So make sure you've got those two definitions written down and then see if you can answer the question at the bottom. Hopefully your answer was that the limiting reactant determines the amount of product made, because it runs out first. There is another phrase that we use in terms of our chemistry, which is stoichiometry. Now, wherever we see the phrase stoichiometry, what we're referring to is a description of the relative amounts of each substance in a chemical reaction. So we're going to do a calculation with this in a second. Here's an example of the kind of question we could see. An oxide of copper, Cu2O, is heated with excess hydrogen, H2, forming 6.40 grams of copper and 0.900 grams of water. Calculate the balanced equation. So what we're going to do here is we're actually going to use a calculation to work out the balanced equation, rather than sitting there and doing it the way we've done previously. So the first thing we need to do is calculate the amount of each of those measured substances, i.e. the ones we've got masses for. So in this case we've got 6.40 grams of copper and 0.900 grams of water. They're the two measured substances. So we work out the amount of copper by doing the mass divided by the molar mass. So 6.4 divided by the molar mass of copper, which is 63.5, gives us 0.10 mole. Same thing for water, mass divided by molar mass, so 0.900 divided by 18, the molar mass of water, gives us 0.05 moles. So what we've done there is we've calculated the amount of copper and the amount of water in moles. Then what we need to do is simplify the ratio of those substances. So our copper to water was 0.1 to 0.05. Now we don't want to use numbers like that, we want to use simple whole numbers. So if we convert those to the simplest ratio of whole numbers, then we end up with a 2 to 1 ratio. The last thing we need to do then is write the balanced equation. So from the question we can see that our oxide of copper, which was our Cu2O, is going to be heated with excess hydrogen, so Cu2O plus H2. And we're going to make copper Cu and water H2O. So we write in our just symbols first of all from the question. Then we look back to what we just said. We said there's going to be 2 moles of copper to 1 mole of water. So all we need to do is put the 2 in front of the copper. And that's it. That's now a balanced equation. So your turn to have a go at this question then. So let's have a look at this answer then. 4.8 grams of magnesium is heated with excess oxygen, forming 8 grams of magnesium oxide. Calculate the equation for the reaction. So the first thing we need to do then is work out the amount of each of our named chemicals here, so the ones we've got the masses for. So we've got magnesium and magnesium oxide. So if we start off with magnesium, then what we've got is 4.8 grams of magnesium, and the amount is the mass in grams divided by the molar mass. And in case of magnesium, the molar mass will just be its relative atomic mass, which is 24 from the periodic table. So that gives us 0.2 mole. Do the same for magnesium oxide. So magnesium oxide we've got 8 grams of, and we divide the mass in grams by the molar mass, so it's going to be 24 plus 16, which gives us 40, and that works out at 0.2 moles. So what we've got is 0.2 to 0.2 is our ratio, which we can always describe as a 1-to-1 because they're the same. Then we're going to write down our actual symbols. So it tells us up here, magnesium's heated with excess oxygen O2. So we can start off by doing magnesium plus oxygen. And it's going to make magnesium oxide MgO. Now, we know that the amount of magnesium is going to be the same as the amount of magnesium oxide. But we've got to look at the oxygens as well. Here, we've got 2 oxygens. Over here, we've only got 1. So we know that's got to be a 2, and because there's 2 magnesium oxide, we know there's got to be 2 magnesium as well. In terms of your marks for that one, give yourself a mark for this first bit, a mark for your second part there, and then you can have a mark if you recognise the ratio and a mark for the final thing. So total out of 4. Last thing to do today then are the plenary questions. So those of you with a target grade up to grade 5, 2 columns on the left. Those of you with a target grade over a grade 5, it's the 2 columns on the right.